Following Griffiths, we're going to make these things. These are called raising and lowering operators. And this is certainly not my cleverness, so I will follow my buck. All right, A plus minus, and we'll define it as 1 over the square root of 2 mh bar m omega, and then times minus plus, so the plus goes with the minus, and the minus goes with the plus, IP plus m omega x. I just laughed about that, sorry. Because I always talk about the books like The Yellow River by I.P. Freely, and How to Jump Out of Planes, written by Hugo First, and things like that. So my kids and I try to come up with names like that.
Robin Banks.
Robert Banks.
Robin Banks.
Robin Banks, there you go. That's a good one. I'll bring that one home to that. Yeah, and then The Fundamentals of Physical Education by Eileen and Bendover or something like that. All right, it goes on. Okay? And so here's the scoop, is now we're just going to do some algebraic, well, we're going to be operator algebra gymnastics. And what's important to notice is that operator algebra is not the same as ordinary algebra. It is going to come down to these things called commutation relations. All right? But for a while, we're just going to play, and at the end, we're going to come to a nice result. All right? So you ready? We're just going to play. All right, so try this. All right, let's try, and again, this is other people's cleverness completely. A minus A plus. So that equals, you ready? 1 over 2 h bar m omega times I p plus m omega x times minus I p plus m omega x. And what I'm going to do is make sure I put in my operators to emphasize when I'm dealing with operators, okay? And this is going to equal 1 over 2 h bar m omega. You ready? It's going to be, let's see, it's going to be p squared plus m omega x squared plus I p m omega x minus I p m omega. No, I think I have that wrong. Let me see this. No, that's right. Px, no, the x and the p switch. So this is going to be IP, so this is going to be plus IP m omega x. Then for my next one, so this is this times this gives me this, and this times this gives me this, and this times this gives me this.
Yep.
Then I need this times that.
Right.
Right?
So it's minus IP m omega x.
Yeah, which cancels.
No, I gotta be careful. So let me be more careful. It's going to be.
Well, just draw lines.
Yeah, it's going to be this times this going that way. So I've got to follow the order.
It's minus m omega x.
So that's that. And then it's going to be this times this, which is going to be that.
And the operators are saying order's important.
All right, that's right.
Right.
And then it's going to be this times that. So I was being a little bit sloppy in my notes. So this is going to be minus m omega x, and then I'll go plus here. M omega x times minus IP. That's better.
This is the easy way.
Yeah.
Yeah, and then this times that. All right? And I think, Matt, you said order matters here. All right? And so when you multiply, you're really multiplying through this one.
So if order matters, you have to move your term, m omega x term.
No, order matters inside.
In the multiplication process, not in the addition process.
The multiplication of terms is not communicated here with the operators.
That's right. All right, Mike wants to do this, so we'll do that. I agree with him if you want to do it like that. And omega x squared. Okay? Alright, but now these are adding. And so adding, you can add anywhere you want. It's a cumulative law of addition.
Yeah.
Okay, so it can go anywhere you want.
So what were you saying about the order matters and multiplying?
The order matters multiplying,
Yeah.
but not at adding. So ordinary numbers, what it's going to come down to is this, is that,
When you're foiling.
Let me give you an example. But 3 plus 2 times 3 plus 2, it's going to be 9 plus, I'm making this complicated. It's going to be,
Yeah, we just covered binomial theorem in my other class. So.
yeah, it's going to be 9 plus 2 times 3, right? Well, let me do it this way. 9, 3 times 3 plus 3 times 2 plus 2 times 3 plus 2 times 2. All right? So here and here, 3 times 2 is equal to 2 times 3.
Right.
Right? So you can write this as 9 squared plus 2 times 3 times 2
Right, which would
plus 2 squared.
be a squared
You mean
plus 2ab
3 squared.
plus b squared.
You mean 3 squared?
Yeah, 3 squared.
Yeah.
All right? But let's say now that we're dealing with operators. All right? So now we have an operator. So say our operator is like x plus the derivative with respect to x. All right, so now multiplying it out, we have x squared plus x d by dx, right? That times that times that.
Yep.
Plus d by dx times x,
Operator.
all right, plus d squared dx squared. All right?
Are you just saying the order in which one you put next to each other matters?
I'm saying the order of operators matter
In multiplication.
in multiplication, but the order of ordinary numbers does not matter in multiplication.
Right.
And so now if you were to put in, like,
I thought you were saying the order in which you multiply them matters. It doesn't.
no, okay.
It just matters like if you, whatever way you multiply them, you just make sure like the one on the left is on the left and the one on the right is on the right.
So now we have x squared plus x d by dx plus d by dx of x plus d squared dx squared. Now, is it true now that these two things are the same thing?
No.
Okay. Okay, so the point there is, for these things called operators, they certainly don't commute. That's me. When ax, when AB equals BA, it said they commute,
Right.
right? And so you write it as this. A comma B is defined as AB minus BA. These brackets are called the commutation relation. And if it equals 0, what you say is A and B commute. Okay, so A times B minus B times A equals 0. So in other words, 3 comma 2.
Right.
Does 3 and 2 commute? Do 3 and 2
Yeah,
commute?
because 3 times
Yes.
2 is the same as 2
So
times
they
3.
commute. However, do x and d by dx, do they commute? No.
No.
They do not equal 0. So what you say here is that A and B commute. X and d by dx do not commute. And so this right here, this right here is called the commutation relation. If the commutation relation is equal to 0, then the two things commute. If they don't equal 0, then they don't commute. All right? So let me continue here, guys, okay? Alright, so, and that's going to be big in physics, okay, and in quantum mechanics. By the way, what numbers? Do ordinary numbers commute?
Yeah.
Yeah, but what do you think of that don't necessarily commute?
Operators.
Matrices?
Yeah, matrices.
Do matrices commute necessarily?
No.
Very not. Right, so that's another connection that quantum mechanics is really just a different representation. This wave function representation is just another representation, maybe a matrix.
That was one of the problems that Heisenberg started with when he came up with
That's
the
exactly
matrix.
right. That's what Heisenberg came up with.
All right, so we got this thing. Now where we go?
Okay, so let's go. So this equals 1 over 2 h bar m omega p squared plus m omega x squared. But now I'm going to rewrite the next part as minus I m omega p x minus x p. Alright, which is now going to equal 1 over 2 h bar m omega p squared plus m omega x squared plus I m omega times xp minus px. Alright, which I'll rewrite as 1 over 2 h bar m omega p squared plus m omega x squared plus I m omega commutation relation of x comma p. Everybody agree?
Yeah.
Because that's just the commutation relation. Okay, so what we're going to do then, okay, so in my notes, this is when I talk about these things. But let's say where we're at so far. So far, what do we recognize as p squared plus m omega x squared as? So, I'm sorry I erased this, but earlier we had that h0 equals 1 over 2m p squared, right, plus m omega x quantity squared.
Right.
That was the unperturbed Hamiltonian of the harmonic oscillator. So look where we're at. We're pretty darn close, right?
Right.
Yeah. All right, so what we're going to see right now is, in other words, and this is a minus a plus equals this. So in other words, a minus a plus equals 1 over h bar omega times h0
Right.
plus 1 over 2 h bar, the commutator of x comma p.
Yep.
All right, you see that? Just a little algebra. Make sure you can do it. So fill in all the steps at home. And so we're very close. So in other words, I mean, I could write it like this. H0 is going to equal a minus dagger, a plus dagger, minus 1 over 2 h bar, the commutator of x comma p, all times h bar omega. That's sloppy. Sorry about that, guys.
So he's solving for H now.
Okay, everybody see that? So, the next thing we want to investigate, right? So we've almost got this new representation again of H0 in this funky form. Right? But now I need to know what the commutator of x and p is.